Welcome to Mathematics with Tom. I am Tom, and today we are going to find the mean, the median, and the mode from a frequency distribution. And I want to show you the motivation for this as well. So here we go. So we're going to find, this is our title, mean, median, and mode from, I'll say from a table. How about that? From a table. There we go. That's what we're going to do today. So what I'd like to do is we're actually going to just calculate the mean from the data set. And this is the data set we've looked at before. This is the first 20 digits of pi. So let's calculate the mean of the data. This will take us a little bit, but that's okay. So here we go. I'm just going to add these up. 3 plus 1 plus 4 plus 1 plus 5 plus. I'm going to put these, I'm going to write it like this so I can help keep track. That's the first row plus the second row, which is 9 plus 2 plus 6 plus 5 plus 3 plus our third row, which is 5 plus 8 plus 9 plus 7 plus 9 plus our final row, 3 plus 2 plus 3 plus 8 plus 4. And there's 20 of those. So we're going to take and divide all of that by 20. So here we go. So the first group of parentheses, 3, 4, 8, 9 plus 5 is 14. Plus 9 plus 2 is 11. 6 more is 17. 17 plus 5 is 22. 3 more is 25. Plus, and you should verify these numbers. There's a good chance I'll mess one up. Next one, 13. 13 plus 17 is 30. 30 plus 9 more is 39. Plus 3 plus 2 is 5. 3 more is 8. Another 8 is 16, and 4 for 20. Take all that. We're going to divide that by 20. And so let's see. That's going to be 14 and 25. That's 39. 39 plus 39 is 78. I think I made a mistake. Let me double check here. I'm going to pause. Oh, goodness. My mistake was in that fourth set of parentheses. Look at this. 5 plus 8 is 13. 13 plus 9 more is 22 plus 7 is 29. Plus 9 should be a 38. So this is a 38 plus 20. So now if we add these up, 39 plus 38 is 77. Plus 20 divided by 20. This is going to be 97 divided by 20. Let's grab a calculator to double check that. 97 divided by 20. 4.85. 4.8. Oops. Where did it go? .85. I just totally lost my screen. Okay, found my screen. So here we go. If we add these up, I have 97 divided by 20. Put that in our calculator. We just saw that's 4.85. I'm going to just, and we said that we would round it. Remember, we round to one decimal more accurate than the data. So our data is in whole numbers. We'd round to the tenths, and so we'd say x bar is 4.9. Okay. It's hard to want to round a nice perfect 4.85, but we will. Now, let's calculate the mean from the data from our frequency distribution, or our table of data. Well, notice that once we have a table of data, for example, we have no idea now in this first class, we have no idea if the data between 0.5 and 2.5, we don't know if those are all ones, they could be all twos, or they could be a combination of ones and twos. We have no idea. So what we do is we use the midpoint as the best representative for each class. So the midpoint is essentially the mean of the class. So I find my midpoint, and often you'll see it abbreviated XM for midpoint. So to find our midpoint, like for the first class, we would take 0.5 plus the 2.5. There's two of them, so then we divide it by 2. Well, 0.5 plus 2.5, that's 3. Divided by 2, we get 1.5. So our first midpoint is 1.5. In other words, we're going to use 1.5 as our best idea of what the data values in that first class look like. And if we continue this, we'll try one more. This is going to be 2.5 plus 4.5 divided by 2. Well, that's going to be 7 divided by 2, that's 3.5. And actually notice that they each go up by 2. The next one, and you should double check this, 4.5 plus 6.5 is 11. Half of that is 5.5. The next one, you have 6.5 to 8.5. That's 15, but divided by 2 for 7.5. And our last one, 8.5 to 10.5, that's 19 divided by 2 for 19, or 9.5. Now, an easy mistake is just to add the midpoints up. But remember I'm going to just start this idea. But really, if you want to calculate x bar, you have to remember that in the first class, there's a 1.5, there's another 1.5, whoops, another 1.5, there's another 1.5, there's another 1.5. In other words, there's 4 of them just in that first class. And then if you go to the second class, there's 3.5s, but there's 6 of those, so you'd write 3.5 plus 3.5 plus 3.5 plus 3.5, 3.5 plus 3.5. And you just keep going and you do this until you've accounted for all of those. You've added all 20 values up, and then you divide it by 20. But look at this. We can, a more efficient way to do this is say, okay, the data is represented by 1.5s, but 1.5 plus 1.5 plus 1.5 plus 1.5, that's the same as 1.5 times 4. It's repeated multiplication. Plus, the next group, the data values, we're representing them with 3.5, and there's 6 of them. Plus, in our next class is 5.5s. We're representing it with 5.5s, of which there are 4. Our next class, we're representing by 7.5, of which there's 3. In our next class, there are 9.5s, of which there's also 3. Now we're going to add all of those, and divide it by 20. And I'm getting tight on space here, so I'm to kind of squish this in. 4 times 1.5, that's going to be 6. 6 times 3.5, that's 18, and 3 more for 21. Plus 5.5 times 4, that's 20 plus 2 more for 22 plus. 3 times 7.5 is 27 plus 1.5 for 28.5. And finally, 3 times 9.5, that's 27 plus 1.5. That's, did I do that right? Oh, no, I didn't. The previous one was wrong. You guys should say something. 22.5 plus this next one's going to be 28.5. Take all that, divide it by 20. Well, let's see. 6 plus 21 is 27. 27 plus 22 is 49. 22.5 plus 28.5 is 51. Divide that by 20. That's 100 divided by 20. Well, that I can handle in my head. That's 5. Now remember, you should pause this and check it with a calculator, for I may be wrong. I do make mistakes. But look at how close they are. When we use the actual data, our mean was 4.9. When we use the information compiled into the tabular form, we got 5. So you can see it's a pretty close representation. Either way, you have a good idea of what the mean for that data set is. The last one, two things we want to do is the mode. So I'm going to come up here. Mode. Let's do the mode. The mode, in this case, we don't have a single mode. It's actually a modal class. Is the most frequently occurring class. In other words, which class has the highest frequency? Well, if you look in there, the modal class is right here. The frequency of 6, it's the class, so in this case it's the class from 2.5 to 4.5. The median. Let's do the median in this pink. No, let's not. That's hard to see. This yellow. The median is the middle. Remember? So if I was to line up all of these dots, the median would be right in the middle of all those dots if I arranged them in ascending order. Well, I'd write out 1.5, 4 of those, and I'd write the 3.5s, I'd have 6 of those, and I'd continue. But notice that I have 20 points written out. Well, the middle of 20 is 10. So if you counted out 10 and you put a line right after the 10th value, you'd have 10 values below it and 10 values above it. So the question is where does the 10th value lie in our information? So in this case, this is pretty slick. In this case, the 10th value, so notice the 10th value, there's the first class has 4. The second class has 6 more. That's 10. Oh, and wait a minute. And then there's 4 plus 3 plus 3. That's also 10. So the median really lies right between the second and third class. In other words, the median is the 4.5. That's what separates those two classes. Or you could take the 3.5, or you could do it, say, okay, well, my second class are a bunch of 3.5s, and then that'd be my 10th value. My 11th value would be the 5.5. And so we want what's in the middle right here. We would add those two together to get 9, divide it by 2, and get 4.5. That's how you find the mean, the median, and the mode from a table of data. Hope that helps. Thanks for watching.